What I'm going to do is kind of go over how to do the math version of the balancing. Okay. And I'll start off with one that you guys all had the answer for before. And that was H2 reacting with O2 to produce H2O. Now, again, if you can't see anything, let me know because of glares or not. I'll try to adjust. But just like before with the drawings, you still draw this down, a line down the middle. Okay, you have your before and after. All the rules still apply. If you guys notice, I did post online the extra rules, the little things to help you guys get through it. There's a picture that I took from our Zoom from last week. Okay. Now, what's different about this is you do not write out H-H anymore. You write down the elements you have. So on this side, I have hydrogen and I have oxygen. Okay. Now, because the law of conservation of mass says that these two have to be exactly the same. So you can rewrite it on this side over here. And I would write it exactly the way you wrote it over on this side. Don't make it any different than the side you're doing on the other side. Why is that? It's because you want to compare going straight across. So it's easier if you can see it that way. So on each side you go, all right, how many hydrogens do I have? I have 2. How many oxygens do I have? I have 2. Over here, hydrogens I have is 2. Oxygens I have is 1. Okay. Now when you're dealing with the math part, you have to deal with least common multiple, not factors. The difference between multiples and factors is what you multiply to get an answer. Multiples are, say, like 3 and 12. Okay? Multiples of 3 is 3, 9, 12, 15. Multiples of 12, 12, 24, 36, 48. And you want to find the one that's least common between them. So this case is 12. So when I looked at these two numbers, you're looking at what numbers that they both multiply can equal, that they both, when multiplied with other numbers, can equal to. Now some of them, when we do this, are going to be pretty simple. Okay, and you'll see that as we go along. First here, when you look straight across, I have 2 here, 2 here. Same, I'm good. Now I'm going to do oxygen here, 2 and 1. Not the same, right? So what we have to do is we have to find the least common multiple between 2 and 1. And the least common multiple between numbers, pretty simple, it's the number 2. Now this is when you look at factors. Okay, what do we multiply to get that answer? So what do I multiply 2 times 2 to get 2? I multiply by 1. Okay? Why is that important? Because the number that you multiply by, not the multiple, but the number you multiply by, that becomes your coefficient. Okay? And then you use the distributive property to figure out exactly how many you have. And the distributive property is used throughout the whole thing. So 1 times 2 makes this equal to 2. On the other side here, now I have oxygen we needed by 2. So for me to get to 2, I need to multiply this by 2. Now this coefficient goes in front the whole thing. Okay? And like I said before, you now again do the distributive property. And the distributive property works on every element present. So now you go 2 times 2, which makes this now 4. 2 times 1, which makes this 2. Our new answers now, the 2 oxygens work, but the problem is now that hydrogen's off. So I have to go again. Least common multiple between 4 and 2 is 4. Do I need to multiply this anything by to get 4? The answer is no, it's times 1. I don't need to put a 1 over here. But this side I need to multiply by 2. That number goes in front. Now, a question a lot of students always have when this comes up is, if I put this 2, does it affect the oxygen? It does not, because of the plus sign. The plus sign is like a comma in English. It says we're separating, and the 2 are being added together. So then you go 2 times 2, and you get 4. Now I'm balanced. And we had done this problem earlier. It's 2, 1, 2. Got the exact same answer, doing the exact same thing. So nothing has changed. The only thing now is just a different way of doing the problem.
Mr. Diaz.
Yeah.
If you can we do we have to simplify it always?
Yes. Okay. You always have to simplify. And the reason why you have to simplify is because you got to think about, when we're balancing, you're actually coming in with whole number ratios. Okay? And when we look at ratios, just like when we did empirical formulas, we like them to be as simple as possible. Right?
Oh, yeah.
Okay? Excuse me. Let's do something like... So I got magnesium reacting with HCl, which is hydrochloric acid. Okay. Draw the line down. Elements I have is magnesium, hydrogen, and chlorine. Now don't go on this side and go in the order of here. Write exactly the way you had it on this side. So you write Mg, H, and Cl. Okay? On this side, I have 1 magnesium, 1 hydrogen, 1 chlorine. This side, 1 magnesium, hydrogen's over here, 2, and chlorine I have 2, right? Now, from our rules from earlier, which element are you going to do last? If you didn't remember from the simplified and or looked at the screen, the 2 ones that you would have the options between H2 and Mg. The one you want to do last is Mg, because this has a subscript of 1. When it's a subscript of 1, those are the easiest ones to do at the end. So you want to keep those there at the end. Okay? H2, if this is the only one we had here, we do hydrogen last. But in this case, we'll be doing magnesium last, because it is the one that is by itself, and it's the easiest one to do. So let's move down to hydrogen. So we'll skip magnesium, even though it is balanced when we look at it. When we're going through it, we want to do them always last. H, least common multiple between 2 and 1 is 2 again. I told you it's going to be kind of common, same things you're going to see. So times 2. That goes in front of whatever element you're dealing with. Again, we use the distributive property. So it's 2 times 1, which makes this 2. Where students make a mistake, you stop there, but it's not true. Because then it's 2 times 1, because there's chlorine there. So now we have 2 chlorines. Okay? This side I don't have to multiply by anything to equal, or multiply by 1. Don't need to put a 1. I could put the 1 there if I want. Now when I did this, hey, it ended up balancing itself. Because once I multiply by 2, I put that 2 up there, everything balanced out, we're done. Okay? This is sodium hydroxide plus sulfuric acid producing water and sodium sulfate. Okay? Now, this one has one of those unique ones that we talked about, that it has a polyatomic on both sides. One of the polyatomics we have is SO4. I see it on both sides, sulfate. Just like in the drawings, you want to keep them together. Keep it together. We also have hydroxide on both sides. And some of you guys are going to say, Mr. Diaz, where the F do you have that at? Well, I have hydroxide here, right? Simple and easy. You actually have it right here as well, because technically we could write this as HOH. Okay? Now, where students get confused on this is because you have to think of this hydrogen is not in relationship with this one. They're two different entities. Okay? So when we write it, again, you draw your line down the middle. Then you have Na. Keep OH together, because that was one of the clues about polyatomics. You keep the polyatomic together. Hydrogen and sulfate. Rewrite the exact same thing on the other side, because the law of conservation of mass says you have to have the same. Particularly if you see the polyatomic on both sides. Now, if you notice, when we broke this up by the polyatomics, oxygens are even broken apart, right? You want to do that because when you keep them together like this, it makes it easier for you. And when you're doing it separate, now you have to do the math about the oxygen over here, then there's oxygen over here, and it just becomes too hairy for you. If you just keep the polyatomics together, it makes it easier for you. You know me, I try to make it as easy as possible. So on this side, I have one sodium. Okay? I have one hydroxide. Hydrogen, I have two of them. I do not have three, because this hydrogen is part of the hydroxide. So this hydrogen by itself is the one I care about. And then I have one sulfate ion. Over here, I have two sodiums. That's that subscript. OH, I have one, and hydrogen, I have one. Because I remember that one hydrogen, this hydrogen's with the hydroxide. Then the sulfate, I have one. Now, one of my clues I had before is that when you do this type of balancing, you want to try to balance the polyatomics first. So let's look at our polyatomics. 1 and 1, that's good. OHs, perfect. Don't have to worry about them. So let's just do our sodiums. Again, 2 and 1, the least common multiple of, hey, pattern, right? Is 2. This side I have to multiply by 2. That goes in front here. I use the distributive property. I now have 2 sodiums. The only other thing that's going to change on this, the only thing that changes on this is hydroxide, not hydrogen. Because the hydrogen's over here, it's separated by a plus sign. I have 2 now of hydroxides. Okay? So my sodium's good. Let's go back. Let's go balance the hydroxides. Least common multiple between this one is 2 and 1. Or so the factors are 2 and 1, so the multiples are 2. Multiply by 2. Put this in front of the whole thing. If I looked at it kind of from here on this one, I have 2 hydroxides, and now my hydrogens changed to 2. Because 2 times 1, 2 times 1. Are you balanced? 2, 2, 2, 1, 2, 2, 2, 1. I'm balanced, I'm done. So the number is 2, 1, 2, 1. And you're done. I'm going to let you guys balance this one yourselves right now. try this one.
Hey, Mr. Diaz, what is that? Was it BaNO4, right? Or
It-
in the beginning?
It's BaNO parentheses NO3 2
Okay.
plus NaCl producing NaNO3 plus BaCl2. When you guys are done, just look up. I have the answer for you. So try it first. Don't just go right ahead and copy it. There's the work for it if you need it. You guys see how that works?
Yeah. So for the top where it says BA, so it says BaN NO3 to 2, right?
Correct.
Parentheses 2.
Saying there's two nitrates.
Thank you.
Now let's do one of the hard ones. I'm going to do two where the math shows you right away how complicated it can get. And also the rule of always trying to do elements by itself. So I'm going to do an easy one first, then I'm going to do one that's going to tick you off. Okay. So list our elements. We have carbon here, hydrogen, and oxygen. List the same ones on this side. You have 1, 4, 2. 1, 2. Now here's where people get confused. We have 3 oxygens. How I have 3 of them? 1, 2, 3. Okay? Now, this is an example where I talk about where you want to do the element that's by itself last. The element in this case you want to balance last is oxygen. Okay? So you want to keep oxygen as the last one you do. Because by itself is easier the math. So you want to balance carbon and hydrogen first. So, carbon and carbon, it's 1 and 1, right? We're good. Now, hydrogen, 4 and 2. Now this is where you got to look at it. Least common multiple between 4 and 2 is 4. I need to only multiply this thing by 1, but here I need to multiply by 2 to equal 4. That number goes in front. Again, we use the distributive property for every element. 2 times 2, we get 4. 2 times 1 is 2 plus 2. I now have 4 on this side. You guys all see how I got the 4, right? Because 2 times 1 is 2, so technically I have 2 oxygens here. Then I have 2 oxygens here, so you add them both together and you get your 4. Okay? Now we go down to oxygen. Since our carbon and hydrogens are balanced, 4 and 2, pretty simple. Same thing we did with the other one. Times 2 goes here. 2 times 2, and I get 4. Hey, I'm balanced. 2, 1, 2, 1, 2. We did this one earlier. It was a part of your homework assignments. Sweet. Times 2 is... So you notice the only thing I changed on this one now is now I have a different element that's starting it off. Okay? Now, while you guys are writing this down, I'm going to say this while I'm talking at the same time. This is a reaction where I'm having something burning. Because when you guys get to the word problems, and advanced kids, you already are, tomorrow, your worksheets for this week actually are all word problems. That whenever we say something's burned in air, it is not burned in nitrogen. It is always burned in oxygen. You know, the weather's been nice enough that some of you guys have probably had fires in your backyard. And if you want your fire going, you need to make sure you add oxygen to it. If you don't let oxygen, you got problems. Kind of like that, if you guys remember the exploding can that we had, that I did in class. When I pulled out the cord from the bottom, and all of a sudden the flame changed because oxygen was able to come in than it was before. All right, so like we normally do, go 4, we have 10, we have 2. This is 1, 2, 3. Hey, it didn't change from the last one. Kind of cool. All right, so we balance first the carbons. We have 4 and 1, so the least common multiple between both of them is 4. So I multiply this by 4. That goes in front. You can do this derivative property for oxygen right now just to kind of get practice of it. But you're going to do oxygen last, so it doesn't really matter right now. But 4 times 2 is 8, plus 1 means I now have 9 over here. Okay? Now we go to hydrogen. 2 and 10. These come multiply both of them as 10. So this gets multiplied by 5 to equal 10. Distributive property now, you get 10. And now I have 13. Okay? Because 5 times 1 is 5. So I have 5 here. 4 times 2 is 8. Add them together, you get 13. Okay, so now if I take this 13 and 2, is there a nice common multiple between both of them? No, right? You guys are going to say, shite, what do I got to do? How do I make this work for me? I'm getting frustrated. Well, if you looked at the rules I gave, and when I took a picture of it, it says, if I get frustrated, you stop. Erase all the work you have done. So, hey, I'm going to stop. Erase all the work I've done. And add a coefficient to my most complex reactant. So when I look at these two, this is basically an element, so I want to add a coefficient to this. The coefficient initially is 1, so now I make it a 2, so I make it up 1 higher. If I go through and the 2 doesn't work, then I go again and add it, make it a 3. Okay? Now, because I had this coefficient, you have to think about how many you have. So if I go 2 times 4, this now is 8 I have. I now have 20 here, because 2 times 10. This day, the same with still being 2. Over here, 1, 2, 3. Nothing's changed. But how we do our math and what goes on is different. Now this is different because now instead of 4, it's now 8. So I need to multiply by this 8. Put that in front. Do use the distributor property. I now have 8 here. This changes to 17 because 8 times 2 plus 1. Least common multiple between 20 and 2 is 20. So I have to multiply this by 10. That goes in front. Use the distributor property again. Now I have 20. Whoops, 17. 10 times 1 is 10. Plus 16, I now have 26. Is there now a least common multiple between 2 and 26?
Yeah.
Yes. Okay, so this is 26. I need to multiply this by 13. So when this reaction goes, I need a lot of oxygen, right? And I form a lot of carbon dioxide and water.
Hey, Mr. Diaz.
Yeah.
Can you help us do one on the worksheet? Like help me.
In a sec. I want to do one more problem and go. Okay. Last one I want to go over that you guys can have and be able to review. And I'll tell you right now, most of these things, when they get complicated, is dealing with organic compounds. And that's using any organic compounds when you have some carbon-based objects reacting with water or with oxygen. So you guys have seen this before. This is sugar, right? Now, advanced kids, you have to start including states of matter in these word problems. If I give that to you. Sugar, we know, is a solid, so your states of matter are solid. So when you see this, S is solid. L is a liquid. Pretty simple, right? G is a gas. Now the one for you guys is called aqueous. And what does aqueous mean? Dissolved in water. Why is that important? If you guys remember from the conductivity lab, when an ionic compound is dissolved in water, it is ripped apart, the electrons have now been exchanged, and now you have positive and negatives floating around. So when you see the aqueous, that means that it's something that is dissolved in water. Okay? Regulars, you guys don't have to worry about those signs unless you plan on taking AP Chemistry. You have to learn what they are, but for you guys, it's not kind of required from you. Plus, if it says I'm burning in air, it's going to be O2. Most likely what state of matter that's going to be is a gas. And then you produce carbon dioxide. This is what goes on in your guys' bodies. Carbon dioxide is a gas, right? And then you might have water either as liquid. For those who wear glasses, you probably have seen it. Because you blow on your glasses and use that mist to clean your glasses off.
So is sugar aqueous or no?
Sugar is a solid. Okay? Okay. So we list our elements like we have been. Carbon, hydrogen, and oxygen. Carbon, hydrogen, and oxygen. Okay? We have 6, 12. We have 8 oxygens here, right? 6, 2. Over here, if you guys notice, the pattern always ends up becoming 1, 2, and 3. Now, when you guys are looking at this, what you have to pay attention, which element we're going to do last? Oxygen, right? That's the one we're going to do last, but you got to remember, it's also included in this one here. So you have to take that math when you get to that point. So let's balance our carbon and hydrogens like we've been doing. 6 and 1, the least common multiple is 6. So I need to multiply by 6 here. Use the distributive property. I now have 6 times 2 is 12, plus 1 makes this now 13 here. Don't worry about it for right now. Over here, 2 times 12, or 2 and 12, the least common multiple is 12. I multiply by 6 here, not 12. Now I use the distributive property again. 6 times 2 is 12, plus 6, I have 18. Now when you look at this, 18 and 8, right? Like crap, how do I do this? How do I make this even on both sides? Well, and is there a common multiple between 18 and 8 right now? There isn't, right? It's something probably really big that we really don't want to care about. But if we kind of look at it this way, of these 8, I've already used 6 of them, right? So really what I have to balance with, I still have the 6, but I have to balance these 2 that are left over. Is there a common multiple between 2 and 8? 18. Huh? 9, right? Okay, but again, we have to look at this. That's 9, right? But we all can, if I have 18 here, how many am I allowed to have over here? 18 only, right? So if I already took 18, I took away 6. What am I really balancing against? What number? Is it 18? Well, let's look at this. Yeah. So if I have 18 on this side equals 6 plus x, what does this x have to equal to? Alex already said it. 12. So I need this here to equal 12. How do I do that? Let's multiply this by 6, right? This is why you do this element by itself. Now, this is where it gets a little complicated because I have to take into consideration this. I can't have more than 18 over here. This is where you have to kind of use a little bit of math and understanding algebra and stuff like that, that there's really no multiple I have to do. I have to take consideration that this side says I have 18 only. That means I can only have 18 here. I already used 6 up in this problem. So I'm really trying to balance this 02 with a 12. So I got a 6. So it becomes 1, 6, 6, 6. Now, when you guys look at that, like, holy crap, Mr. D, this is a lot. Well, I'm going to only give these to you guys hard ones. If you can do hard ones, that means like on a test or a quiz, you can do the ones that are going to be on the test or quiz. You know what I'm saying? Okay, I'm not going to give you an extremely hard one, but I want you guys to work through the hard ones so you understand what's going on. All right, so that concludes this, and it's going to conclude my taping.